This is under chapter 4, covalent bonding. Now I want to explain what is the polar covalent bond. Okay, so polar covalent bond. Actually, covalent bond have two type of bond. Covalent bond can be polar and non-polar covalent bond. Okay, now what is a polar covalent bond? Alright, so bonding, electron share unequally between two atoms. Okay, share unequally between two atoms. Okay, one atom adopt partial negative charge and one atom adopt partial negative charge. Okay, and dipole moment occurs separation of the charge. Okay, I explain one by one. Okay, what is mean by unequally share unequally between two atoms? Okay, so each element they have their own electronegativity value. Okay, if you refer on your data booklet, okay, page 8, okay, every element have their own electronegativity value. Okay, such as hydrogen 2.2, lithium 1.0, beryllium 1.6. But some atom doesn't have electronegativity such as neon, argon because they are already stable octet. Okay, but some group 18 have electronegativity such as xenon because xenon is an exception compared to the others noble gas. Xenon can form covalent bond actually. Okay, so this we call electronegativity value. Okay, from the electronegativity value we can find the electronegativity difference. Okay, I give one word. We call electronegativity difference, or we just write electronegativity difference. Okay, so how to calculate the electronegativity difference? Okay, first refer on your data bullet. What's the electronegativity value for hydrogen? Hydrogen 2.2. Hydrogen 2.2. Chlorine 3.2. Okay, 3.2. Okay, so electronegativity difference between hydrogen and chlorine 3.2 minus 2.2. Okay, 1.0. Okay, 1.0. Okay, so from this value we can determine which is bond is polar or non-polar. Okay, now refer from my table. Okay. Okay, if the value of electronegativity difference, okay, En equal to 0 or until 0.4. Okay, this molecule is non-polar covalent. Okay, remember that covalent bond have non-polar and polar bond. Okay, if the value electronegativity difference is 0.4 to 0.5, 0.5 to 1.8. Okay, we call it as polar covalent, and greater than 1.8 is ionic bond. Okay, ionic bond. Okay, so we back to the slide. Okay, now the value is 1.0. 1.0 is polar bond. Polar bond. Okay. Why polar bond? Because the electronegativity difference, electronegativity value of chlorine is greater than hydrogen. Okay, the higher the electronegativity, okay, meaning that chlorine will attract this pair of electron more towards chlorine atom. Okay, this pair of electron attracted more towards chlorine atom other than hydrogen atom. That is why we call it share unequally. Share unequally. Okay. Now, okay, the higher electronegativity will become partially negative. Partial negative. and the less electronegative will become partial positive. Okay, positive. Okay, and then if the bond have a polar bond, at the same time, the dipole moment occurs. We call dipole moment. What is dipole moment? Dipole moment is the attraction of electron towards another atom. So in this case, electron are attracted more towards chlorine. So this is dipole moment. Okay, this is how to draw dipole moment symbol. Small arrow. Okay. So non-polar covalent bond. Okay. Okay, this is an example lah. Example of bonding in molecule. We have covalent bond and ionic bond. Okay, ionic bond don't have polar and non-polar because they're not sharing electron. But for covalent bond, it have polar and non-polar. Polar unequal sharing because it have electronegativity value and electronegativity difference in between 0.4 to 1.8. Okay, okay, alright. So for non-polar, electronegativity difference is in between 0.4 to 0 lah. Okay, 0.4 to 0 Okay, this is non-polar. Okay, so two atoms involve formation and covalent bonds are identical. There is no dipole moment. Okay, what is mean no dipole moment? No dipole moment meaning that they are sharing equally. Sharing equally because the force of attraction towards A and towards B is equal. They have the quite similar force of attraction. Okay, but for polar bond, this pair of electrons are attracted more towards B compared to A. That's why A will become partial positive and B become partial negative. For non-polar covalent bond, there is no partial positive and partial negative. Okay, alright. Okay, so that's all for the polar and non-polar. Okay, on the next chapter, I will explain about the dipole moment.